Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're in here with my 10-inch 1908 Milwaukee shaper. And we just fired it off and lubed it up and started getting it ready. We have a project here that we're going to be playing with on the shaper, and we're going to be making another shaper part. We're actually going to be building a clapper assembly. So your compound pivots around and feeds it in and out, but your clapper's what controls the relief for the backstroke on the tool bit, and a slight bit of adjustment of angle and all that, because you have an adjustable post in the middle here so that this can pivot around. I just finished modifying my Armstrong holder here so I could take a little stouter bit than I've been able to, so I can actually get a 1/4 by 1/2 inch bit in here. So a quarter inch on the width and a 1/2 inch on the height of the tool gives me a little bit better load capabilities on a bit here. I went ahead and I just did a shallow and a slight little radius right here, because we're just going to be facing off some blocks here to start off. That's going to make our two components. All right, the piece of material I have is behind me here, and we're getting ready. We're going to go put it in the bandsaw, and we're going to go ahead and cut a cut across here, and then we'll have the body. You can see the template right there. You know, the closest that I could get to the material was 6. This is actually 5. This is about 8 long. This is a foot piece, so this should be enough to make the clapper itself. All right, now you can see that our clapper we're going to be making is just a little bit less than double, and just a little bit less than double on the width as well. And it basically has this component, the backing plate, which actually has a bolt down here, and then this one here lets that pivot, and that's because your lead angle of the tool bit, but the relief angle that you need on the backswing. Sometimes you need that, you know, sometimes you can lock it solid when you need to, but sometimes you need to have it flapping, and you want it flapping away from your part so that there's no excess tool pressure drag on your tool bit. Okay, so it comes on up. And sometimes people hook up little springs and things like that, just kind of, you know, all kinds of different ways to make it return the way you want it to. The other part is this block right here, which has a bore in it with a flange recessed here, and then just a clearance for holding your tool blocks. And Larry Noak from Lakeview, Oregon, is who we're doing this for. He gave me specific dimensions for this part that he wants for his holder, so we're going to be incorporating that. All right, so basically we got 1, 2, 3 pieces that we're going to be making. Now some of it I'm going to be doing in the shaper, and some of it we're going to be doing on my other machines, like the K&T or the Bridgeport, or even in the lathe will be one of the first stops that we'll make for probably the back side of the block itself. We might face that off in the lathe. It just depends on how we're doing on cutting. Okay, so I got to get out there, cut that, and we'll get it back in here, and then we're going to start stroking it. All right, we brought in our piece after we cut it, and you can see here that that's about the size of it. First thing we're going to do is we're going to take the width down to our 5-inch. So we're going to be shaping off. We got plenty of material on there. We're going to be taking at least 1 inch off combined on both sides there. It's pretty close on the length. This piece here will definitely make us a clapper unless we find another piece of ductile or cast iron material in our collection there. All right, now the very first thing we got to do is we got to get this set up to start stroking it. Okay, we put our piece back up on the counter because we realized that this wasn't open far enough. All right, so we're bringing it out here to a little bit better than 2 3/4. Now we already know that it's going to set on the vise. Now we know that this vise is only 1 inch and 5/16 deep on the jaws. So to stand up that 6-inch piece here, and have it basically go like that with every pass, we're going to rotate this thing sideways so that we have the whole length and the leverage of the whole part carrying the load of the chip. And instead of a little 2 3/4 inch little cut and flexing this whole thing at this height, we will be traveling 8 inches and taking less as far as how much the cut travel is. Cut travel side to side, depth will be in the vertical. All right. So you can already see that I have to lower the table down. So let me bring you into a better position to watch the setup. Okay, right after I cut that material and I started realizing I had to drop this down, I brought this down, and this jam nut was underneath here for the last setup when we were working that keyway in the bore of that giant fan we were doing a year or so ago. I first made this rest, and this is faced off with the travel here, and this is a weldment nut here, 2 bolts, 3/8 bolts, go up through here. 9/16 is the head size, so that's where my head was at. So what I've done is I took the jam nut out of here and put it up here and I had to cut some off of the end here, so I may have to make another rod if we ever need it back up in the height, up in, real far up. If we have to bring the table far up, I may run out of travel and may have to cut another rod. But that's what you do in the machine world. Is you make up the tooling, you modify it, and then if you have to, you make up secondaries or additional components to go in there. One thing that's nice is just a 1-inch thread, and you can use over the nuts the same in this piece here. So basically, it's just going to be another rod with a nut welded to the bottom and then faced off parallel with the surface, because you need to support your knee when that load comes across. You support your knee on here. So once you basically set your table at different heights, you lock it down to the machine, and then this takes the load. When you're coming off this end of your cut on the travel, your load is coming down onto this foot. And of course it wants to slide as well, so that's why this is machine parallel flat to your travel surface. So you bring this on down and you just barely get yourself your support so that you can slide freely, but it holds the support. It's just a rest. It's just a knee rest. Okay, what I got to do now is lower the table down by holding the scale here. I'm going to hold it on this side here. You basically know what I'm doing here, and I'm going to go ahead and crank it down until I have that 6 inches of clearance under my tool bit that I just happen to have in here now. All right, and then I'm going down past it, and I'm going to come back up, kind of like the same thing I do on the knee of the K&T or the knee on the Bridgeport. Same kind of thing. All right, put that right there. All right, now we're going to go ahead, and before we do anything on that, we're going to lock the table. This is why you want walk around room. Kind of nice. I started deciding to get rid of some machinery and set up the machinery I do have with a nice walk around. Everybody's going, I had plans on making this place bigger, but I'm not wanting my overhead to be bigger, so we keep it simple. All right. Now we're going to be happy there. The rest of our travel adjustment can be up or down on our compound here, and we can turn it a little bit to the side. We could do a lot of things to adjust our touch-off height. And now I'm going to go ahead and bring this down to where I'm just touching that right there. I know it's going to slide back and forth, and then we can go ahead and we can lock our jam nut as soon as we get a bigger crescent wrench. In fact, we don't even need a crescent wrench. I'll just grab my other very useful adjustable tool. You want to get in an argument about how to pronounce the name? I'm not. All right. Okay, and then your side-to-side motion, like that. Very nice. This could be tested with putting an indicator on mag base on the knee itself, and an indicator here, seeing if it's absorbing all of that you need, and then you can adjust it if you really want to get serious or you had extreme pressure. We don't know what we're going to put on this thing yet. Remember, this is just a little baby shaper. I think I only got a horsepower on it. Is that what I have in here? Let me see. Okay, 1 horsepower, 3-phase motor. And it's belt drive, and the belt, I let it loose with my chain tensioner, so it's the weight of the motor and everything else. We may add belt pressure to this to get my action that I'm probably going to want to see out of this thing. This is not like a mechanical or a hydraulic full-blown shaper as far as its chip load. And it is only a 10-inch stroke. All right, just giving you a perspective of the size of this. All right, now, and one of the things that really was pleasing when I bought this shaper for $175 in California, and it took a while rebuilding. It was one of the first machines I rebuilt, and it had the original vise with it, and that was just totally awesome when I got that with the whole package. I mean, there were some things that needed to be done seriously. Okay. All right, now we want this stroke to be as square as possible here, so I'm going to go ahead and get a square and come off of here and this face right here and just square this up. I think I can grab this flat surface right here, and then this side of my square. Okay. Okay, now I need this wrench bent. I'm just taking the table all the way over that way there. And before I do that, let's add just a little bit of oil on my ways here. All right, now we know we got enough on there. All right, I like that. All right, now I believe we can put our piece of material in there. And the first thing we ought to do is put some T-nuts and items in here so that this block doesn't just push right off of the end. Yeah, that might be a good idea. While we're at it, we might as well wipe underneath it. Looks pretty clean, but let's make it 100%. Earbuds. Okay, there's our little tray for miscellaneous tooling that we know that are little studs. I kind of dug those out on the walk over here. We made the T-nut slots, or T-nuts, a long time ago for this thing. We had those slid in the side there for that last jig we had for working that keyway on that tapered hub there. I never have, but I need to get some large pattern 7/16 nuts. Be nice to have on here. Give a little better footprint here. You can see how this lower shaft comes over, and it's just a bevel gear set right here, and then an Acme thread, and that's an Acme nut right there, and that's kind of as simple as raising this thing up and down. It doesn't really have a graduation or anything else on a dial. It's as simple as it can be. Now, side to side does have graduations, and you do have graduations up on the compound itself. All right. Now let's go ahead, and we want to set our part in here, and I'm going to do that. I didn't tighten the vise down, and I'm going to kind of put this equal in the vise. Okay, and this doesn't have to be super tight right now. I will super tighten it when I get ready to cut on it. Alright, so we've set up our stroke on the lengthwise instead of going across, and we're going to be making the most out of it. So now what we need to do is position our vise and set up our stroke. Went and shut off the air compressor. I don't really need the air on right now, so I don't have that interruption. Alright, back to setting up our stroke. We're going lengthwise on our part. For one, the grip on the jaw will allow you to hold stronger and have less flex and less rocking on a part that's taller than your vise. So with that said, I got this in neutral. I haven't engaged the motor, so I can rotate this around. Position of ram is controlled by this handle up here, and the length of stroke is on the rotation of this hub right here in relationship to the arm. By rotating this, it puts the cam in the linkage so that the powertrain going back and forth that's going to push this, and I'll give you a show of that through the window door on the other side once I get rolling. But right now I'm just going to tell you that I'm going to adjust it here, and there's graduations from 0 to, it only goes up to 9, but it has more to go past 9. We're going to be doing about a 9-inch stroke right here. So just this one nut right here. And then you go ahead and rotate this around. Alright, I'm lined up. There's 9 inches of stroke. So it's kind of a combination of you holding the handle in the center and rotating your pulley, your drive. Okay. There we go. Okay, 9 inches of stroke. So now our stroke length, we're about a 1/4 inch back behind our part right there. We like to be somewhere around a 1/4 inch before our part would be ideal. And then we're going to rotate this over or out till we go past our part, and we're about 1 inch or so. So we could safely move this out about a 1/2 inch on our knee, and we'll be pretty good on our stroke. I'm going to bring this back on over here just so it's closer, and then make sure my nuts are loose here, and slide this on out. That looks like a 1/2 inch. We're going to rotate it, and it's about a 1/4 inch before the part. Okay, we're happy with where it's at right there. We would probably like another 1/8 of an inch on the start of the cut. So we're going to go ahead and loosen this here, and we're going to go get the rubber mallet so we're not hitting things with our hands. Okay, I just grabbed the rawhide mallet here. All right, just a tap back, tighten that up. Yeah, it's like 5/16 now, and about 3/8. I think we've got that pretty well covered in a good position right there. I like that. All right, I like that one. While we have this right here, this is a good time to go ahead and show you how the mechanics of a shaper work and how you can recognize that the rotation needed by your motor on a shaper on a belt drive, even if it's V-belt or whatever coming up, and you need to decipher that direction, or you're looking at something that's set up and you want to know if your shaper is running backwards. It all has to do with the stroke and the ram against the cam. All right, there's a rotary cam in here that is connected to this axis of this shaft right here, and a pinion gear runs on a ring gear, and as that ring gear goes around, then the eccentric of the pivot point moves out or in towards the center. When it does that, it has a forward stroke and an aft stroke, or a back stroke. That pin is working the top side of the pivot against the bottom side of the pivot, meaning it takes longer to go from 3 o'clock to 9 o'clock than it does to come back from 9 o'clock to 3 o'clock, because you're going to be running a longer stroke in the open area and a faster on the tighter area. So when you rotate this here, the ram goes as a power feeds out. As soon as it gets there, the backstroke, see how much fast, I'm turning it the same, but how fast that comes back. All right, let's look in the door and you'll see the perspective of it. Let me reach in here and open up the door. You can see that this is the original door, and it gives the date and everything about the patent and all of that. And open up the door here. Now I'm going to go ahead and rotate this around, and you see how that cam is off of that center piece, but as it goes over the top, it takes longer to go over that top than down here at the bottom, because it's short towards the pivot. Remember, the pivot is at the bottom of the machine and the ram is at the top of the machine. Alright, now I'm going to drop the belt down so that you can see it move under its own power. Alright. Okay. The next thing we do before you forget, and you have to pick your vise up and your part off the floor. Yeah, it is something when you get a shaper set up and you don't have everything quite tight, and you hear it go boom. All right, now we're going to go ahead and give this a good cinch on the vise here. All right, I like that. And I think we're stout there. All right, now I'm going to bring this out here to the end here so we can actually kind of see what we have here. I have a very slight radius here on the bottom here. a little bit of a radius off of each end. The sides of that tool bit are perfectly square, and there's a little bit of relief on the bottom side here. A little tiny bit of scoop or positive rake on the very front of it. Very, very slight. I haven't stoned this, but sometimes once I get going and I'm happy with the tool bit that I'm using, it's performing fine, I will stone it. I'm just kind of seeing what I can do with this tool bit for right now. We're going to be hogging off some, so really if you're going to hog off, you just kind of want to really grab a good least resistance, which would be just off the side of your tool bit. So this one may not do me well, but I'm going to go ahead and grab my Allen wrench. In fact, actually, I could go ahead and just use it that way, and now I'm using the bottom as my cutting surface because I'm going to be feeding across the part in that direction. Now I may have to loosen up the Allen because I'm going to loosen up this nut here a little bit because I want to give it a little bit of angle this way here so that when the pressure comes back, of course it's going up there, but I want it to come back this way a little bit too, so it has a little bit off the end of this surface right here. It doesn't take much. I'm just going to give it just a slight bit. Like that. And come down here and come across here. I just want to see how much clearance I got right here on my part. Okay, that's going to be good. There'll be plenty of clearance there. I want to keep it as stout, short and stout as I can. All right, let's make sure. You want to make sure everything is tight when you're concerned about a shaper here. And it's also nice to have a little bit of oil on everything here. My clapper is just slightly loose on side to side. It's just had many hours on it. All right. Now we're going to go back over here so we can touch off on it. All right, motor's down, we're set, we're ready to go. We are in our low speed. All right, now I'm just cranking down slightly on the compound until I get a touch here. Okay, just starting to touch at the very beginning. Okay, we're just rolling it through. Okay, we're touching, and that touch off brought us to about right there or so. So we know that this cut here is probably not perfect with there, and also too, after a couple cuts we'll find out if we're actually cutting true in our vise and if we have to modify or do anything from there. That's why I say some of the things I might be doing in the shaper and some of the things I'll probably be doing in the mill and things like that, but I would like to put some time in on the shaper and show what I can get out of this little 10-inch 1908 Milwaukee. Okay, I'm going to crank her on over to here to the side, and I'm going to go ahead. First off, I'm going to look and see where the marks are. And okay, I see a little punch mark up there at the front. It looks like 25 thousandths, I think that is. Alright, and we're just going to feed this over by hand first because we want to get a feel of it. Okay, you can tell that belt's slipping a little bit under a load there when it first catches that. So let's see what we can do about putting more belt pressure on this thing. Alright, I found a place where I think at one time there was a spring plunger that went over a part there. I put it back on the shaper, it was there, and somehow I think there was a receiver and there was a spring in there at some time, or an adjustment, a threaded rod or something at that time. But I took a measurement and it was basically 6 inches in there, and then I pushed it, preloaded the motor, and I created close to 6.5. The part that I found in the rem box there was 6.5 inches long, so I got it in there. It's got a pretty good load on it now, and my belt is tight. All right, let's see what we got now. Oh yeah. Oh yeah, she can get it done now. Okay, I think we're going to set our auto feed now. The auto feed consists of a ratchet paw that has a little ramp on one side and a straight drop on the other side, and it works on a cog, a square tooth cog on this side here. You can see that. Alright, and then you choose your position on which way you want to put the angle of the cog. If you put the angle facing one way, it's going to move and then come back and ratchet that direction, and if you turn it and you put it the other direction, it's going to click the other way and ratchet that. How far that actually goes determines on how far you have this slid off of the center line. So the other side is controlling the ram travel distance, and this side here is adjusting the amount of feed travel. Alright, now here's another thing that when I lowered this down, I didn't loosen this adjustment. This adjustment loosens right here, and this is like an extendable rod. And you leave that in neutral. You can move this wherever you want, and because you want to be able to get to this knob, so it's probably best if it's somewhere in that area there, and you can change that after you roll it around if this is in the right position and you're happy with it. And while you're staring at it, you go ahead and put a drop of oil in there. All right, and also in here. All right, and all right, so basically and I'm going to come back off of this part here so that I can watch. You watch your adjustment here, and you can watch the amount of increments that it takes per cut, and that's how you'll gauge. This basically just has 0, 1, 2, 3 to 6 that direction, and 1 through 6 the other direction there. And it looks like they took a hand punch and a chisel, and they made that work there. And also too, actually, somebody that, you know, back in the day, that's how they made the little pointer. So it was a round piece that was in there, bent over and then shaped and everything else. Pretty nice looking little piece of material. They put a bolt and a washer on each side, so this won't accidentally go out past the travel, and you don't drop parts on the floor and lose them and things like that. Alright, now I'm going to fire this off, and I'm going to go ahead and put it in a position. And also too, you have a little notch on here, and that notch is on the right hand side, or in line, excuse me, I should say in line. So you're either going to put that notch facing that way or put that notch facing this way here, and I believe that tells you which direction it's actually going. We'll verify that here, or the opposite direction. All right. We're going to put it this way here. All right, it is coming out. And it's coming out 7 thousandths a pass. Okay. All right, that's tight. Now I can go ahead and I can, excuse me, it's out this way here, so what it's doing is bringing the table towards us. So I can crank this in. It's better if I'm looking at it because I can see it. Okay, we're going to be coming up on it now. Okay, I put it in neutral. I'm going to stop it, and we got the same thing on this side here. There's a pointer on both sides, and it's on 2 here as well. Alright, so now I'm going to go ahead and I'm going to move it to 3. Put this back on the point there. Okay, we're going almost 12 thousandths right now. Per pass. Alright, we're going to need to get a brush so we can brush off our top of our part there and start looking at our finish, and then we're going to determine where we're going to go from here. And we know that we can increase the amount of feed now that we got sufficient pressure on our belts. Alright, and there's our first pass across the part. Okay, we vacuumed up all of our big chips. We're just breaking this edge right here. Ductile material is pretty nice, but you don't have to work on it too much. It doesn't leave big hanking burrs and everything else on there. Cast iron material, ductile material. Okay, break this lube. We're going to flip it over. We could continue on here again, and I know we have a little mismatch here, but we'll flip it again probably one more time. But right now I just kind of wanted to go ahead and get a cut on the other side going. And we're going to take this out here. It looks clean enough. We're going to put it back in there. Okay, 50-50 here. We're going to make sure that our backstroke there, we like that, about 5/16 of an inch. Okay, are we ready to see if it takes 50 thousandths this time? Let's see. There we go. All right, let's put the feet in. Now we're talking. All right, until next time, get her done.